Key fundamental point about evoked potentials is that it's the only way of showing in a human that there is demyelination. So I'll just break that down a bit. So one of the key things about MS is that the attack is on the myelin of the nerve, leaving the underlying nerve fibre intact. And the result of that, as far as the nerve is concerned, is that electricity passes much slower. Now, the only way of testing whether that's happened in a human directly is to actually put electricity into the human and see if it conducts down a nerve slower. And there are three basic ways of doing that. The least used one is something called the Brainstem evoked potentials, where there's a clicking noise outside the ear and electrical impulses pass through the ear nerve and into the brain and the brainstem, and they're recorded here. Next is something called somatosensory evoked potentials, where literally some stimulation is applied to the arm or the leg, and the speed with which that travels all the way up the limb and into the brain is recorded. And then the most common form, which people may still be asked to do, even at the time of diagnosis of MS, is the visual evoked potentials, and consist of someone watching a black and white chessboard flashing, so that's a stimulus, and then some wires put on the back of the head measuring the electric current over the scalp. And that is a poor man's version of the electrical activity in the brain, in the visual area. By flashing lots of times and by recording lots of times, you can get an idea of how long it takes for a change in signal out there to be registered in the eye, to be transmitted all the way through to the visual part of the brain. And in people with MS, that's slowed down because, very typically, the optic nerve, which is a nerve connecting the eye to the rest of the brain, has been demyelinated, and so the conduction of electricity has slowed. So this used to be, evoked potentials, and particularly visual evoked potentials, used to be a really common part of the diagnostic workup of someone with MS, particularly before MRI scans, because you could actually say this person has got demyelination. Okay. The reason that we still have evoked potentials, and particularly in clinical trials, is because if you're doing a trial of a drug that you think will repair demyelination, such as the trial of bexarotene in Cambridge at the moment, then you want a direct measure of remyelination. And so we use evoked potentials, particularly visual evoked potentials, to measure how fast the nerve, the optic nerve, is conducting before treatment and then after treatment. And what we would hope is an effective drug causing remyelination would result in the visual evoked potential being shorter or faster. And that would show us that the optic nerve has been repaired. Well, the thing that is curious, that might surprise you, is that if you take a random group of people with MS who've never experienced optic neuritis, at least half of them will have abnormal VEPs, visual evoked potentials, suggesting they have indeed experienced optic neuritis in such a small way that it wasn't obvious to them. It takes about half an hour. The electrodes are applied directly to the skin with a bit of jelly and then some tape over them, and sometimes you have to force the hair apart to get a bit of a good landing strip, sometimes even shave a tiny bit of hair to put the electrodes on. And depending on how the visual evoked potential is done, that might mean just 3 electrodes on either side, or 2, or sometimes more, 8, up to 8.